CMI Corporation has never been completely satisfied with current technology. No matter how good hot mix asphalt plants are, for example, we know there are ways to improve them. Such an improvement was found in the town of Hamar, Norway. For the past 18 years, the Amico company had been manufacturing a new type of air filter unit, different from anything made in the U.S. and in several ways superior. CMI is licensed to manufacture this type of unit in North America under the trademark of Roto Aire. Roto Aire baghouses operate without air compressors, multiple diaphragm valves, solenoids, air piping, venturis, or other mechanisms that create most of the problems associated with jet pulse or reverse air baghouses. The Roto Aire uses a draft system in which cleaning air is distributed through a mechanical rotor. This very simple and reliable mechanism is all that is required to perform a continuous and effective cleaning operation. The rotor can be seen better in the shop while the unit is under construction. In this upper area, each section of bags is partitioned off from the others to control air distribution. From underneath, we can see the rotor in operation. In this drawing, we can see the sections of bags, and the rotor is in the middle. When the rotor is not active, it's in this null position. After dust particles have caked up sufficiently on the outside of the bags, the rotor begins stepping through its cycle, allowing air to be channeled into one section at a time. The airflow is strong enough to release the caked dust from the outside of the bags. It falls to the collecting hopper and is augured back into the drum. Perhaps we can see the airflow better without the bags. CMI makes a full range of Roto Aire baghouses, from 30,000 to 150,000 cubic feet per minute. We visited one Roto Aire unit in operation in the mountains of Idaho and talked with its owner, Don Poe.
Oh, Rich Meehan, our plant superintendent, and our general superintendent, and our plant foreman, Louis Thompson, and myself looked at several different asphalt plants, and we decided on the CMI. Thought their technology was good on their computerized operation of the plant. The portability of it was excellent. And we've been having real good luck getting, good setup time and getting the plant put together. A lot of the jobs we have now seem like it takes longer to set up the plant than to do the job. We're spending more time mobilizing because the plant size or job sizes are rather small. So the bag house is a new concept, just a lot less operating parts to it. It's smaller in size, which is an advantage in portability. We haven't had it long enough to know what the life of the bags are going to be, but so far it looks, real good. We're real happy with it. Well, we had the EPA come in and test on a state of Idaho job, and the plant did pass the first time. I have the results here. The testing people came out with an emission of 0.0112 grains per dry standard cubic foot, and the allowable particular emission rate here is 0.04, so the test came out real well.
Although the Roto Aire concept is reasonably new in North America, it is well established in the European area with over 700 units in operation, most of them on hot mix asphalt plants. For high production, long life, reliable, trouble-free operation and economy, CMI's new Roto Aire baghouse is the answer.
For the past 20 years or so, the asphalt production industry has been building and using storage silos which are all basically the same. And they all have a flaw designed into them. Here's what I mean. In operation, the drag conveyor deposits small amounts of hot mix asphalt into a slug feeder at the top of the silo. The purpose of the slug feeder is to reduce segregation of material by increasing the mass before it is dropped into the silo. But let me show you what actually happens. As these small amounts of material fall to the center of the slug feeder, a coned pile is formed. This is where the trouble begins. The finer material tends to remain in the center of the pile, while the larger aggregate tends to roll to the side. So segregation has already begun. When this material is batched into the silo, it goes through a round discharge opening in the center of the slug feeder. As the finer material is discharged first, the coned peak becomes inverted to form a funnel or rat hole. Then the larger aggregate, which had collected around the outside, rolls to the center and goes in last, causing secondary segregation. When the material falls into the center line of the silo, the segregation process is repeated and further aggravated because the silo is much wider than the slug feeder. The fine material stays mostly in the center, while the coarse particles roll much further to the outside. When the material is discharged from the center of the silo, the same rat hole problem occurs. As material is loaded into each truck, the same segregation process is repeated. When the truck unloads into the paver hopper, the larger aggregate remains along the outside wall. As the walls are raised to clean the hopper, the large aggregate goes in last. So the segregation that began in the slug feeder continues directly into the laydown process. With the asphalt industry moving toward large stone mixes, this silo design will cause even greater problems in the future. CMI Corporation, with its reputation for innovation, has tackled this problem head-on. As part of our energy management system, EMS asphalt plants, we have completely redesigned storage silos using features never before seen by the asphalt industry. We call the new silos Uniflow. The slug feeder is split in the middle, giving the effect of two separate feeders. This allows the side walls to be very steep, in fact, almost vertical. The discharge opening at the bottom of each side is a 5-foot-long rectangle. From a top view, it looks like this. While the old-style slug feeder batches material down the center line, the EMS slug feeder discharges it near the quarter points. And because the sides are nearly vertical and the discharge openings are so wide, the entire batch of material flows in mass when the gates are opened. So we've handled the material through the slug feeder without segregation. Inside the silo, the material is mass flowed to the quarter points, so no cone effect can be formed. Instead, two slight mounds are formed, which continue to maintain the even blend of mix. At the bottom of the silo, the discharge is also divided into two sections. The walls are very steep, and discharge gates are 6 feet wide. These openings are 90 degrees opposed to the openings in the slug feeder. We can see this clearly from a top view. The red slots are in the slug feeder, and the blue slots are in the bottom of the silo. So you can see that at no time is the material fed down the center line of the silo. Therefore, segregation is virtually eliminated. As the gates are opened, the material mass flows so that the even blend is not disturbed. The 6-foot-wide gates at the bottom of the silo are turned crosswise to the driveway. So when the material is loaded into a typical 8-foot-wide truck, it loads the full width of the truck, again avoiding a peak pile and its related segregation. And since the material is evenly blended in the truck, this blend is maintained into the paver and into the road. These points can be illustrated clearly with the use of working scale models. The old-style silo on the left and the new EMS silo on the right. First, the old style. As the gates are opened in the slug feeder, rat holing and segregation become apparent. Inside the silo, we can see that the larger aggregate has rolled to the outside. And as we open the gates to load the truck, again, rat holing is clearly seen. Now, the EMS silo. When the gates are opened on the slug feeder, there's a mass flow of material. Looking inside the silo, we see that the large aggregate is evenly distributed. And when a truck is loaded, all the aggregate in the silo moves in mass. There is no segregation here. Going from models to the real thing, we'll look at some of the other advanced features of the Uniflow silo by CMI Corporation. The cones on both slug feeder and silo are designed with long-wearing, abrasion-resistant liners. In order to maintain the integrity of hot mix asphalt over extended periods of storage, two things must happen. The silo must be sealed so that no more oxygen can get in, and all oxygen must be removed. CMI's unique silicone elastomer seals totally isolate the mix from the atmosphere. These sure seals are located at both top and bottom of the silo. At the top, clam gates on the slug feeder swing open and closed by pneumatic cylinders at both ends. These gates are mounted on cam assemblies, arms with offset shafts. When the arms are activated, the shafts and gates go up or down. The normal working position is down. Here, the gates are free to swing open or closed. Directly above the gates, seals are mounted onto the slug feeder, so that when the gates are pulled upward, an airtight seal is formed. At the bottom of the silo, clam gates swing outward to open and inward to close. They are also mounted on cam assemblies and pulled upward to initiate an airtight seal. The optional inert gas generator effectively removes all oxygen. Temperature of the stored mix is also very important. In the EMS silos, walls contain 5-inch thick super heavy-duty insulation with an R value of 21.7, the highest in the industry. The top of the silo has 10 inches of insulation, and the bottom cone is heated with circulating hot oil. The EMS drag chain conveyor is equally advanced. It's designed for long life and low maintenance and has a capacity of over 650 tons per hour. The drag chain is a single super heavy-duty roller chain with 6-inch pitch, specially designed for high capacity. Flights are 3/4 inch thick, made of carbon chrome molybdenum alloy with a minimum Brinell hardness of 360. The head sprocket is made of tri-segmented Nyhard and is carried by a massive 7-inch high alloy shaft. It is on a pillow block with tapered roller bearings. The chain is driven by an electric motor and 3 stages of speed reduction. The first stage is a belt drive, which allows simple ratio changes to match production requirements. The second stage is a planetary gear reducer with cooling fan. The third stage is a high-strength roller chain which is fully enclosed in an oil bath. The floor of the drag conveyor is lined with ceramic tile for abrasion resistance, and it's heated with circulating hot oil channels which run the full length of the conveyor. Sideliners are 1/2 inch thick hardened steel with a Brinell rating of 500. The Uniflow silo and drag conveyor are parts of the complete energy management system, the most efficient hot mix asphalt plants in the industry. And every part of this system lives up to the CMI motto, quality by design.